Alright guys, so in part 2, we finished section 3.1.4, activity 2, numbers 2 and 3. So today in part 3, we're going to finish part 4 and hopefully move on to the next section. So part 4, this is one of the most important questions. It will most probably come in written as well. Anyways, the figure shows a sketch of a part of a curve C with this equation, alright? So I'm going to underline it over here, this equation, which meets the x-axis at the origin and at two other points. So at this point, which is the origin, at this point, and at this point, right? It meets the x-axis. This is point A, which is 1, 0, and then this is point B, right? Part A of the question is find the coordinates of B. So we need to find coordinates of B. And then this statement over here is for part B and C, so let's ignore this. So what we have to do, we need to find the coordinates of point B. They gave us this curve, 2y is equal to that, and then it meets the x-axis, right? So we need to find the x-intercept, or the roots of the function. How do we do it? Let's first solve for y, because this is given to us in a pretty strange way, right? They said 2y is equal to that expression. Let's solve for y. So I'm going to do it here. So this is question 4a. Solving for y, because y is equal to 3 over 2x cubed minus 7 over 2x squared plus 2x, right? Now we notice that we can factor out an x, so it's equal to 3 over 2x squared minus 7 over 2x plus 2, all multiplied by x, right? And then since they said they intersect the x-axis, that means y is 0, right? So we can equate this expression over here to 0. Now we have the inner part, sorry, I didn't mean to do that. We have the inner part, which is the quadratic equation, and then we have this x over here. That means we know that x is equal to 0. It's a solution, right? If x is equal to 0, that means this is 0. It will multiply this whole thing, which is not 0, by 0, which gives 0, which is true. So x is equal to 0. That's one of the roots, right? Now we need to solve for the other two roots. So we have 3 over 2x squared minus 7 over 2x plus 2. This can also be equal to 0, right? Solving for this gives the two roots, which are labeled by alpha and beta. This is equal to negative b, so 7 over 2 plus or minus 7 over 2 squared minus 4 ac over 2a, which is 3. This is your standard quadratic equation, right? Now, alpha gives, let's see, 1, and then beta gives 4 over 3 using your calculator. If calculators are not allowed, then just solve it. So 7 over 2 plus or minus, let's see, we have 49 over 4 minus, those 2's cancel out, so minus 12, which is 48 over 4 over 3, 7 over 2 plus or minus, this is radical 1 over 4 over 3. Radical 1 over 4 is just half, so 7 over 2 plus or minus half over 3. So two cases. We have 7 over 2 plus half over 3, 7 over 2 minus half over 3. For the first case, we have 8 over 2 over 3, which is 4 over 3, right? And then we have 6 over 2, over 3, which is just 3 over 3, which is just 1. So we have our alpha and beta. So this is alpha, this is beta. It's not that hard without a calculator. Anyways, so those are the two roots. So those are also solutions to our equation. Those are the roots, right? Now, let's see. They gave us that it meets the x-axis at the origin. That means one of the points is 0, 0, right? And we predicted that, we solved that by letting x equal to 0. Y is always 0, right? Another answer is 1, 0. This is alpha. This corresponds to the alpha thing that we found. Alpha equals to 1. That means the x is equal to 1. Y is always equal to 0. That corresponds to the point A that they gave us, Now that we want to find b, right? So the other one is we use beta, which is 4 over 3, 0. That means our point b is 4 over 3, 0, and we solved part A. Now let's do part B and C. The normals to the curve C at the points O and A meet at the point N, right? So the normals to the curve C. Now we know that, so we have those 3 points, right? This is O, this is A, this is B. O, A, B. The tangent of O looks something like this, tangent of A looks something like that. The normal at O looks, I don't know, something like this, right? It's perpendicular to the tangent. And the normal at A looks something like this. And then they said that the two normals, they meet at the point N. So I'm going to label this is point N, right? We need to find the coordinates of this point. So N, we need to find the coordinates, right? And then for part C, they said calculate the area of the triangle OAN. So here's a triangle, the green one. This is your triangle, and they want us to find the area. Let's do B first. So to find the points of intersection of their normals, we need to first find the equations of the normals, right? How do we find the equation of the normals? We know that the slope of the normal is the negative reciprocal of the slope of the tangent, right? What is the slope of the tangent? It's the derivative, right? So what we can do, we write our equation again. So this is our curve, y equals 3 over 2x cubed minus 7 over 2x squared plus 2x. We take the derivative. This is equal to 9 over 2x squared minus 7x plus 2. Now, this is your derivative, but we need to evaluate this derivative at some points, right? They said that we want to focus on point O and A, right? So let's evaluate the derivative at y prime. What's the x coordinate of O? Is 0, right? So x is equal to 0. This is equal to, set x equal to 0, we'll find that it's 2. And then the same thing for x is equal to, let's see, we want for point A as well. What's point A? It's 1, 0. So the x coordinate is 1. Solving this gives 9 over 2 minus 7 plus 2. Let's see, 9 over 2 minus, this is 14 over 2, so it's negative 5 over 2 plus 2, which is 4 over 2. This is equal to negative half, right? So we know that y prime at x equal to 1 is equal to negative half. Now, what do they even mean? We found those two values at those 2 points, at points O and A. What do they mean? They mean the slope of the tangent, right? So we found that the slope of the tangent at O is equal to 2, and the slope of the tangent at A is equal to negative half, right? That means that the slope of the normal at O is equal to the negative reciprocal, which is equal to negative half, right? We say 2, negate it, and reciprocate. And then the slope of the normal at A is equal to 2, right? Now, using those information and knowing that point O is 0, 0 and A is 1, 0, we can find the equations of the normals. So y minus y0 equals to m of the normal at O, x minus x0. So y minus, well, for O, the point is 0, 0, right? So we can simply say that y is equal to negative half x. This is the equation for O, the normal at O, right? Now, for the normal at A, same thing. So y minus y0 equals to the slope of the normal at A into x minus x0. Y minus 0 is equal to 2x minus 1. So y is equal to 2x minus 2. This is for the normal at A. So now that we found the normal lines, we need to find their intersection points, right? 1 second. They said that those two normals, they meet at the point N. What do they mean? They meet, that means they intersect at the point N. How do we find the intersection point? I did that in the last video already. We equate those two lines together. So it's negative half x is equal to 2x minus 2. Let's see, negative half minus 2x is equal to negative 2. So half plus 2x is equal to 2. Sorry about the handwriting, I'm in a rush. Half plus 2x is 2.5, x is equal to 2, x is equal to 4 over 5, right? So we found the x coordinate of the point of intersection. Now we need to find the y coordinate, right? Since those two lines intersect, it doesn't matter where we substitute our x into, whether we substitute into this equation or that equation. It doesn't matter since they intersect. We choose the easier one, right? So we choose this one. So y is equal to negative half of 4 over 5. This is equal to negative 2 over 5. That means the point N, which is the point of intersection, the coordinate of that point is 4 over 5, negative 2 over 5. And we solve part B. Now, for part C, they asked us to calculate the area of the triangle OAN, which is in green. Now, we know that the coordinate of O is 0, 0, the coordinate of A is 1, 0, the coordinate of N is 4 over 5, negative 2 over 5, right? So, what is the area of a triangle? It's half base times height, right? We'll choose the easier base and the easier height. The base that I'm going to choose, denoted it's in red, will be this base. So that's the base, and the height will be this height. That's the height, right? So the area of triangle OAN is equal to half base times height, which is equal to half. What's the length of the base? It's 1, right? Since the distance between O and A is 1, so base is 1. And what's the height? Now, this is where you make a mistake. You'll say that the height is negative 2 over 5 because the y coordinate of n is negative 2 over 5. That's wrong because the height will be the absolute value. It's always positive. Right? So the height is 2 over 5, not negative 2 over 5. Computing this will give 1 over 5. So the area is 1 over 5 square units. Don't forget to put the square units, even though they didn't give us any units. That's why we put u squared, which is square of the whatever units we have, okay? So we finished question 4. I think this one was easier than question 3, but they're both equally as important, and probably both of them will come in written. So make sure that you know questions 3 and 4, okay? Those are like the most important questions. Of course, later, I think in the next video or something, I'll do the workbook questions. Those will come as well. Moving on, now we're in section 3.2.1, and I'm going to try to solve activity 1, 2, and 3, all 3 of them in this video. Should be easy. This is just find the derivative, which we know already. We have y is equal to x to the 4 plus 1 over x to the 4. Rewriting this gives us y is equal to x to the 4 plus x to the negative 4. Now, this is still y, so y prime is equal to, take the derivative, which is 4x cubed minus 4x to the negative 5, right, is equal to 4x cubed minus minus 4 over x to the 5. Here's your derivative. Activity 2. Given that y is equal to 4 over x cubed, find the gradient of y at x is equal to negative 1. What do you mean by gradient? Gradient is the derivative. Gradient of y is the derivative of y, right? So y, get white, y is equal to 4 over x cubed. That means y prime is equal to negative 12 over x4, right? I think I can do the derivatives now. And they said that we need to find the gradient at x is equal to negative 1. We need to evaluate this derivative. So evaluating this, because y prime at x is equal to negative 1 is equal to negative 12 over negative 1 to the 4, which is negative 12. So we finished activity 2. Moving on to activity 3. Okay, this one is easy as well. We have y is equal to 3x4 minus 10x squared plus 2 over radical x. That means y prime is equal to 12x cubed minus 20x. Now for 2 over radical x, it's 2 over x to the half, right? Which is 2x to the negative half. Taking the derivative is 2 times negative half x to the... What's negative half minus 1? Minus 2 over 2, which is equal to negative 3 over 2. So x to the negative 3 over 2. Cancelling out, this gives negative x to the negative 3 over 2. Sorry, negative 3 over 2. This gives negative 1 over x cubed, take the square root. So, minus 20x here. So, minus 1 over the square root of x cubed. This is your derivative. Now, of course, you could rationalize. How do you rationalize? We notice that this is this negative 1 over that. So, let me write it again. Right? We could split it up, so we can have x squared times x, right? Which is that. Now this will be x radical x, right? Now multiply up and down by radical x to rationalize. We have negative radical x over x squared. So instead of writing negative 1 over square root of x cubed, we can write y prime is equal to 12x cubed minus 20x minus square root of x over x squared. So I think in exam they want the rationalized form. Okay, I'm going to do section 3.2.3 activity, which is the quotient rule. I'm surprised that there isn't any product rules in the revision sheet, but I think we'll encounter some in the workbook. Anyways, let's do this. We know that the quotient rule, if we have f of x is equal to u of x over v of x, that means f prime of x is equal to, now draw a line, right? Denominator, square it. Now, derivative of the first, keep the second, minus, keep the first derivative of the second. This is how Miss Adia does it, and I think this is probably the easiest way to memorize this formula. Anyways, applying this formula to our question here, so f of x in this case is equal to x cubed plus 1 over, handwriting please, x cubed plus 1 over x squared plus 1. Now, this means that u of x is equal to x cubed plus 1 and v of x is equal to x squared plus 1. That means f prime of x is equal to, draw a line, denominator squared, so x squared plus 1 squared. Derivative of the first, this is 3x squared times the second, which is x squared plus 1, minus, keep the first, x cubed plus 1, multiplied by derivative of the second, which is 2x. Simplifying this, let's see, this is equal to, distribute the numerator, which is 3x4 plus 3x squared minus 2x4 minus 2x over x squared plus 1 squared. Simplifying the numerator gives x to the 4 plus 3x squared minus 2x over x squared plus 1 all squared. I think this is the final answer. Keep the denominator like this. Don't expand the denominator. It will make things messy. Keep it like this. Okay, so now we have the workbook number 1, which is still the same section, section 3.2.3. I'm going to speed through those, okay, since it's just the quotient rule, and I think that you all know this already. So, for part A, y is equal to x over x squared minus 1. That means y prime is equal to, draw a line, x squared minus 1 squared. Derivative of the first, which is 1, times the second, which is x squared minus 1, minus, keep the first, derivative of the second, which is 2x. Simplifying this gives x squared minus 1 minus 2x squared over x squared minus 1 squared, which is equal to negative x squared minus 1 over x squared minus 1 squared. This is your answer. B, we have y is equal to x plus 1 over x minus 1. So y prime is equal to x minus 1 squared derivative of the first, keep the second. So x minus 1 minus keep the first, x plus 1. Derivative of the second, which is just 1. Now, this is equal to x minus 1 minus x minus 1. So it's over x minus 1 squared. This is minus 2 over x minus 1 squared. That's your answer. Part C, let's see, what do we have? Y is equal to x squared plus 1 over x squared minus 1. Same thing, y prime is equal to x squared minus 1 squared, 2x x squared minus 1 minus x squared plus 1, 2x. Distribute, we have 2x cubed minus 2x minus 2x cubed plus 2x. Sorry, minus 2x here, minus 2x over x squared minus 1 squared. This is equal to minus 4x over x squared minus 1 squared. Final answer. Part D, we have y is equal to x radical x over x squared plus 1. Now, okay, same thing, y prime is equal to x squared plus 1 squared. Let me draw it better. Derivative of the first. Now, this is you can do it multiple ways. You can do it using the product rule, or you can just say that this x radical x is equal to x times x to the half, which is x to the 1 times x to the half, which is x to the 3 over 2, right? So derivative of the first, which is 3 over 2, x to the half, which is square root of x, times the second, x squared plus 1, keep the first, minus keep the first, times 2x, right? Simplifying this gives 3 over 2 radical x, x squared plus 1, minus 2x squared radical x over x squared plus 1 squared. Now, you could do some simplification here. So let's multiply the numerator by 2 and the denominator by 2. Okay, so we can get rid of that 2 over there. So this gives 3 radical x into x squared plus 1 minus 4x squared radical x over 2x squared plus 1 squared. Now, we could also distribute the numerator, which is 3x squared radical x plus 3 radical x minus 4x squared radical x over 2x squared plus 1 squared, which is equal to negative x squared radical x plus 3 radical x over x squared plus 1 squared. Now I think we can, 2x squared plus 1 squared. Now let's factor out x radical x. So this gives us, I think this is it. I think that's as much as we simplified as much as possible. Okay, now for E, we have y is equal to x cubed minus 1 over x squared plus 1. That's a cube. Okay, so y prime is equal to x squared plus 1 squared, 3x squared into x squared plus 1 minus x cubed minus 1 times 2x. Distribute, so we have 3x to the 4th, 3x to the 4th plus 3x squared minus 2x to the 4th plus 2x over x squared plus 1 squared. Simplifying this gives x to the 4th plus 3x squared plus 2x over x squared plus 1 squared. That's your final answer. Now for part F, y is equal to 2x over x squared plus 1, so that means y prime is equal to x squared plus 1 squared. 2 into x squared plus 1 minus 2x times 2x. Distributing gives 2x squared plus 2 minus 4x squared over x squared plus 1 squared is equal to negative 2x squared plus 2 over x squared plus 1 squared. Factor out the 2, so we have 2 into 1 minus x squared over x squared plus 1 squared. That's your answer. Okay, so I think I'm going to finish off this part here. For the next video, I plan to finish the revision sheet. We're going to cover the chain rule and the additional exercises. See you in part 4.